This video is going to explain how to do number 5 from your Graphing Rational Functions worksheet. So to start, we want to see if we can factor. 5x and x plus 1 are both already factored, so we don't have any factoring to do, which also means that we don't have any factors that cancel. Since we don't have any factors that cancel, then that means that we don't have any points of discontinuity. Next, we're going to figure out our vertical asymptote. In order to do that, we want to figure out what makes our denominator undefined. If you're not sure, you can set your denominator equal to 0 and solve. When we set x plus 1 equal to 0, we figure out that if we plug in -1, that makes our denominator 0. Therefore, our vertical asymptote will be at x equals -1. Let's graph that. Next, we need to figure out our horizontal asymptote to help determine our end behavior. Our degree of the numerator is 1, because 5x to the first power, and the degree of the denominator is also 1 because x is raised to the first power. Because the degree of the numerator is the same as the degree of the denominator, then we're going to divide our leading coefficients to determine the horizontal asymptote. So the leading coefficient of the numerator is 5, and the leading coefficient of the denominator is 1. That comes from the coefficient in front of the leading term. So 5 over 1 gives us our horizontal asymptote of y equals 5. Now we can graph that. Next, we're going to figure out our y-intercept. In order to determine the y-intercept, we're going to plug in 0 for x and then figure out the y-coordinate. So when we plug in 0 for x, we get 0 over 1, which is 0. So that means that our y-intercept is 0, 0, which then, because it then crosses the y and x-axis at that point, that's our x and y-intercept. We also know that that's our x-intercept because that's what would make our numerator equal 0 as well. To find the other points, to see what else is going on in my graph, I don't really know what's happening on the left side of my vertical asymptote. I'm going to plug in x values to find other points. So I want to know what's going on the left side of my graph. So I want to know if my graph occurs above or below this horizontal asymptote. So I'm going to plug in -6. When I plug in -6, we have -30 over -5, which is +6. So that means we have a point at -6, then up +6. So we'll graph that point. Just to make sure we see that our graph ends up going toward our vertical asymptote, I'm going to pick one other x value to plug in, and that would be -2. So -10 over -1 is going to be +10. So -2, +10 is another point on the left side of our vertical asymptote. So now let's figure out what's going on the right side of the vertical asymptote, a little below our horizontal asymptote. We know that our graph is going to occur below the horizontal asymptote because that's where our intercept is. So if I pick a value to plug in, like 4, then 5 times 4 is 20 over 4 plus 1, which is 5. So 20 over 5 would give me 4. So that means that other point is over 4 and then up 4. So we can graph that. Now we have a good idea of where in to draw my curves. So coming from -infinity, my graph then approaches my vertical asymptote, and coming from +infinity, my graph approaches my vertical asymptote from the right. And that is all.